Okay, guys and girls, our objective today is to write and solve proportions. So we're still talking about proportions like we did yesterday, but they're going to get more difficult. Okay, so plan for today. If there's time, Kevin, we may move on to a short geometry extension, which will still use proportions if there's time. If not, just proportions. Okay, let's start with going over homework. Hey, where'd number 1 go? Oh, yeah, thank you. That's why. Okay, practice 6.2. Thanks, Steve. All right, Joseph, we'll start with you. What did you get for number 10? Good, 35. Steve, number 11? Close. Camille? Good, 88. Number 12, Kevin? Good. Number 13, Skylar? Did you say 5? Close. Jackie? Good, 15. Ray, 14. Good job. 15. Gio? Good, 27. Amberly, 16. Good. David, 17. Good job. 18, Michelle. Good job. Okay, there's the answers for 10 through 18. Make sure you've checked those. Nathan M. You didn't have to do those. Okay, 22. Abigail, what did you get? Good. Greta, 23. Good. 24, Shane. Good. 5 rolls. 25. Let's see here. Camille. Say that again. Good. 20 hours. Just didn't hear you. 26A. Alexis. Good. $2.50. Josh. 26B. Good job. Nathan S. 26C. Great job, man. You guys did awesome on that. Okay, anyone need me to go back to the previous page? Or does anyone have questions? Kimberly? Yeah. Okay, number 12, let's take a look at. Number 12, using cross products, Amberly. If you take 65 times x, you get 65x. And then 15 times 13, you get 195. And then divide both sides by 65. So 195 divided by 65 is 3. You either divided wrong or multiplied wrong. I'm guessing divided wrong. Okay. Anyone else? Questions on any of those? Sure? Wow. Okay, so easy, I take it? Okay, let's go. Steve? 11? Okay. When you multiply across both ways, Steve, you end up with 5x equals 440. Okay, so if you multiply wrong, that's probably the problem, which is something easy to fix. Anyone else? Okay, let's go over the warm-up, and then Miss Wingrove's going to tell you guys about something. So let's do warm-up first here. Yeah. Okay, the warm-up was page 7 in your notes. I told you there was the 2 parts to the warm-up and then 2 parts to example 1. So page 7 in your notes, go ahead and flip to that. Yeah, there were 2 parts to it. I told you guys to do A and B on the warm-up, and then there was an A and B for example 1 that you could have done. Okay, David, on the warm-up, what did you get for letter A? Good job. Greta, for the warm-up, letter B? Great job. Let's see. Abigail, for example 1, what did you get for letter A? Yes. Good. Do you know what they each simplify to? If not, that's okay. Okay. Did anyone simplify them? I know I didn't tell you to do that. Greta? Say that again? No, I think you divided it. Actually, no, that's not right. You're looking at example 1A, right? Okay. Gio? Good. Each of those are equivalent to or simplified to 3 over 17. Okay. All right. Drew, example 1, letter B. No. Those ones are not equivalent. When you simplify them, they are not equal. Okay. Okay. Any questions on any of those? Positive? Okay, Miss Wingrove's going to tell you guys about something that she made for you guys for this semester to kind of help your grades a little. Okay, so listen to her for a couple minutes, please.
All right, so there's a step called PreAlgebra. So this is a worksheet that you can earn 5 and 6, actually 6 extra credit points for this semester.
That's a lot.
So there's a Sudoku here, and there's letters across the columns. This is column A, B, and so on. There's rows. The rows are numbered. So row 1, row 2, row 3. Down here there are equations, variables on both sides of the equation. You have quantities that you can call it, so comes with it. There's 10 of them that you have to do, and then you'll fill in the different cells. So like for this example, the solution is x equals 2, and it tells me to put it in E form. I have E on the top, I put it on form, and then it goes into that cell right there. So there's 10 of those. You'll get 10 numbers for our hard level Sudoku. If you want a little easier Sudoku, there's 5 extra ones at the very end that you can do to get 5 extra numbers to put in the Sudoku before you solve it. Does everybody understand? You have to do the 10. You can do an extra 5 if you want to use your Sudoku for more numbers to do.
Does anyone have questions for her about how to do that? Anything like that? Go ahead, Gio. You can ask her. You got to ask Miss Wingrove. It just will not take you as long, I would think. You know, we would think.
You have to do at least 10 of the equations in the equation. So that's why you're getting credit from the Sudoku and the equations. Most of the points are for the equations.
We haven't decided yet for this class. We'll see how they are, and then, well, that would be much more beneficial. So let's see how things go with this chapter and how you do on that, and then we'll talk. Anyone else? Okay, you excited about that? I know you guys would like that. Miss Wingrove decided she made that a part of her Penn State experience. So, and you guys like Sudoku. Out of all my classes, I think you guys like that the best. Wow, I didn't know that. They are. Oh, I didn't know that. Wow. Swingrove, I didn't know that. Cool. Kevin's happy. Kevin, you'll have a much better day because of that, right? Who else in here really likes Penn State? Okay, or maybe you just like them. Okay. All right, so everyone's good with the bonus bulletin board, right? And there's a pocket folder out there that Miss Wingrove put the worksheets in. So just like the last bulletin board you had, you may take a worksheet out of the pocket before or after class. I just don't want you working on them during class, okay? Not right now. Either beginning, like before class starts, or after. As we're walking out, if you want to get one, you can. Okay, there might be a mat dash today. What did you say, Steve? Well, I'll remind you. Miss Wingrove will remind you too. All right, page 7 of your notes, let's continue. Cross product. So I told you about this a little bit yesterday. Your book does not start this until this lesson. They don't really bring this up until now. So you kind of already know how to do this. A cross product of 2 ratios is the product of the numerator of one ratio and the denominator of the other ratio. And again, if your back is to the smartboard, feel free to turn around if you need to. The groups, I promise, will be moved tomorrow. We'll be back to normal seats. I did, and Miss Wingram and I realized that the 9th graders didn't finish their group test. Steve? Yep, Monday. Next Monday, you'll come in and you'll have new seats. Thursday or Monday, Kevin, I said. I figure if I tell you Monday, then if it happens Thursday, you'll be really excited. Okay, cross product of two ratios is the product of the numerator of one ratio and the denominator of another. So you know there's 3 ways to write a ratio. You know they have to be completely simplified. And if ratios are set equal to each other, you know that you can use cross products to solve because those are going to be equivalent ratios. Okay, this example should be underneath your definition. Yeah, it is. You don't have to write down this top part. Don't worry about this. Okay, what I do want you to jot down is make a butterfly like we did yesterday. 8 times 15 equals 6 times x. And I wrote that down here. And I just left it with the multiplication symbol between it. You do not have to multiply. That's just an example of how you set up a cross product. This is how we solved the problems on yesterday's lesson. Again, the book does not introduce it until lesson 6.3. Okay, so don't worry about the part that's in black with the variables. Just make your butterfly with 6 times x and 8 times 15. Okay, questions on the definition or on the first example? Okay, let's do some examples together. Okay, looking at letter A, please, I will tell you, do not go ahead of me. Last year, I thought that this would be pretty easy because it's similar to 6.2. Students ended up making silly mistakes throughout the chapter on this. So don't go ahead of me. I want to make sure that we take our time and go through this together slowly. Let's make our butterfly. We need to solve for x. 3 times x minus 6, and then 2 times x. So make your butterfly. I now want you to look at the problem. What is different about that than the problems we did yesterday? There's actually 2 things you could say, but Greta, what's one difference? Good. There's an x on both sides. What else is different from yesterday? Abigail? Good. So it wasn't an expression. It was just a constant or a variable. Good job. So there's 2 differences. There are x's on both sides, and then there's an expression here instead of just x or just -6. Here's what I want you to do first. Take 2 times x, jot that down, because 2 times x is 2x. Now, the other part, be careful. We have to take 3 times all of this. So let me ask you, if we had to take 3 times all of this, what do we need? Without me saying it. Camille? Awesome. So what do we need? We have to distribute, but what do we need? What kind of symbol, Camille? Awesome. We have to distribute, so we need parentheses. So we have 3 times x minus 6. You can't just say 3 times x minus 6 and not have parentheses. So make sure there's parentheses, okay? That's the biggest difference when you're setting up your cross products. So let's now start to solve. Rewrite your 2x. 3 times x is 3x. 3 times -6 is -18. This is kind of like the Sudoku bulletin board. You're solving an equation with variables on both sides now. Yesterday we did one-step equations. Okay, is everyone with me so far? Okay, now, what would be the easiest thing to do next? Amberly? Good. Now, the way I taught it to you is take the smaller coefficient and move it to the other side, but you also want all the variables on one side, all the numbers on another. So you will save yourself a step if you move 3x to the other side. Now, do you have to do it this way? No. There are several different ways you can solve this. But let's do it the way Amberly said. We end up with -x or -1x equals -18. Shane, how do we get rid of the negative in front of x? Good. Multiply both sides by -1 or divide both sides by -1. Same thing. Doesn't matter. I have a habit of always dividing, but you may multiply. Whatever you guys prefer. This goes away. We're left with x equals +18. Now, if you wanted to check your answer, how could we do that? Jackie? Good. So we could take 18 and put it in for x. So we have 3 over 18 equals 2 over 18 minus 6 is 12. Are these equivalent? Is 3/18 equivalent to 2/12? What do they both reduce to? Amberly? Good. Both of these reduce to, I'm just going to circle them, both of these reduce to 1/6. So yes, they are equivalent, which means we solved it correctly. Okay. Any questions on any part of that problem before we do some more? Okay, let's go to letter B. Okay, letter B, let's make our butterfly. Anytime you have equivalent ratios with an equal sign between, you're using cross products. So you're making your butterfly. We're going to multiply across both ways. 4 times m is 4m. Okay, 4 times m is 4m. And then multiplying the other way, we have 5 times m minus 6. 4 times m is 4m. And then we have 5 times m minus 6. That's where distributive property comes into play. So we are going to rewrite our 4m, distribute the 5 through. We have 5m minus 30. Okay, Mike, what's the next thing that we should move to make it easy for ourselves? Yeah. Yep, I would move 5m to the other side. That way you have all your variables on one side, all the numbers on the other. 4 minus 5 is -1, or just negative m. And you're left with negative 30. So negative m equals negative 30. And then, Joseph, how do we get rid of the negative? Good. Multiply or divide both sides by -1. The negatives are going to cancel on the left, and you end up with m equals 30. Bless you. Questions on that one? Okay, I want you guys and girls to try letter C. I'll give you a couple minutes. Okay, so try letter C. You should get a nice answer. You can be right there. Yeah. You're quick. Yes, awesome. You guys are fast. Awesome. Good job. Good job. Good job. Are you doing okay? Okay. And Peyton, was Blackboard okay? Did you check it yesterday? Okay. Good job. Good job. Good job. Great job. Very good. Are you guys and girls finding this pretty easy? Okay. Oh, where's your negative? Forget about your negative. Good job. Good job. Good. Good. Good job. Good job. Good job. Great job. Good job. Good job. All right. Just about those of you that I saw, at least, which was just about all of you, you guys got a equals -2. So does anyone need me to go through any part of that? Have any questions? Okay, above those, I want you to add letter D. Above those, I want you to add letter D. Yep. Okay, letter D, we have 1.6 over x equals 8 over 25. So the reason I gave you this one is we did not do any yesterday with decimals. So just to make sure that you understand, when you're solving proportions and using cross products, you don't have to just use integers. You can use rational numbers as well. Abigail? Oh, geez, hold on. You guys are ahead of me here. Speedy. Okay, x times 8 is 8x. Abigail, let's start here. What is 1.6 times 25? Good. Everyone agree with Abigail? Okay. Okay, good. Drew, what's the next thing you have to do? Good. Divide both sides by 8. Abigail, what did you get? Good job. Everyone get 8 or get 5? Any questions on that? Okay, let's flip your page over to page 9. We are skipping a page. Is that locked? I just realized that. Hello? I'm typing looking sideways. Why isn't it working? That was weird. All right, guys and girls, so we're going to start this today. This is a short extension of geometry. The reason this is in here next is you can use proportions to solve for missing side lengths or missing angles with geometric figures. When you get to geometry in 2 years, you will use a lot of proportions, and you'll use cross products to solve them when you get to that in 2 years. So what's one thing that you guys and girls remember from geometry from last year or from 2 years ago? Ray? Lines. What else do you guys remember? Gio? Good. Ray? Jackie? Good. Line segment. Abigail? Good. Points. Josh? Good. Plane. Joseph? Okay, like solve for a missing side or a missing angle. Yep. And that's what we'll get into eventually. Camille? Sure? Okay. Kevin?
Circle.
Good. Circle. Jackie? Good. Vertex. Awesome. Josh? Good. Diameter. Shane? Good. Pi. Gio? Good. Parallelogram. Okay. First thing I want, yep, angles. First thing I want you to jot down is point. So the notation for point, if the point is A, it'll be point A. A diagram for point, in other words, when you see point, it'll be a dot or a point, and then the capital letter for what the point is. Second one, line. Notation for line is going to have a small or tiny line above whatever the line is. You always use 2 capital letters to represent line. So in this case, BC. Even if there were 3 letters on the line to the right in the diagram, you still use 2 letters to name it. A diagram, remember, your line's going on forever in both directions, so it's a line. Okay, it's going to keep going. You have to have these arrows here for it to be a line. Okay, and then the last one is a plane, which I always describe kind of as a piece of paper. So if this was our plane, it's a flat surface. Okay, you will name a plane typically by 3 letters, but your book uses 1 letter. When you get to geometry, you'll name it by 3 letters that are on the plane, but are not on the same line. Okay, which is called non-collinear. Mr. Warnock will explain that to you in 2 years. Okay, let's take a look at this diagram. Make sure you guys paid attention to that. Can someone name us 3 points that you see here? Amberly? Yep. Yep. Good. So point J, point K, and point L. Since they ask us to name the points, you can just list them. Okay, what about 2 lines? You can give us 1 line. Nathan S? Good. JL, Nathan S, what goes above it? Good. Make sure you guys and girls put a line above it. We need another line. Grace? Good. KL, Grace, what goes above it? Good. If it's a line, make sure you put a line above it. And then plane, Jackie? Good. Plane P. I'm just going to draw a plane and put a P in it. You can also just write down plane P. Either way. Okay, so there's our plane. Okay, before I flip to the next slide, does anyone know, guys, does anyone know what congruent means? Oh, a lot of you. Joseph? Good, exactly the same. Does anyone know what the symbol is for congruent? No? Okay. Okay, congruent. I want you to jot down. If things are congruent, as Joseph said, they have the exact same length. They have equal lengths. The symbol for congruent is an equal sign with a squiggle line above it. So this is the symbol for congruent. You'll see this a lot in 2 years. It's an equal sign with a squiggle line above it. That means congruent. Miss Wingrove and I saw this a lot in college, especially with the geometry proof class we had. You guys will see this a lot in your proofs in 2 years and with application problems in the book. If we had an example here and we said, okay, these two segments are congruent. These are segments because there's just a line above it, okay? This would mean segment AB is congruent to segment CD. Jackie? Say that again. Oh, that's because it was just my messy writing. It's an equal sign with a squiggle line above it. Okay? It doesn't have to be perfect. Obviously, mine's not. If you have two shapes, and these should not be here. So let's say we have two triangles, and we need to show that they are congruent. You can use tick marks. One tick mark on each side means these sides are the same. Two tick marks means this side is the same as this side. Three tick marks means this side is the same as this side. So if your tick marks match up, that means those sides are equal or congruent, which we can then assume that this figure is congruent to this figure. Gia.
Would there only be one tick on the left and right since they're the same?
Well, I did not draw them to scale. And that's going to happen a lot in geometry where it's hard, especially for me, I can't draw, to freehand and draw them so that it matches up exactly the way you want. So, you know, maybe I meant to make that this side's a little bit longer or a little bit shorter. It just doesn't look like that. A lot of times your geometry book will say underneath shapes not drawn to scale. Okay, so you have to look at the notation or the symbols so you know what that really means. Does that make sense? Okay. Drew, you're not playing on your calculator, are you? Of course not, right? Any other questions on congruent? Okay, let's talk about one more thing here, and then I'm going to save the rest for tomorrow. Congruent angles, so still means that they are equal, have the exact same length. Okay, and you're still using the same symbol for congruent. Here's an example of an angle. Little angle symbol in front kind of looks like a less than symbol. But this means angle P is congruent to angle Q. So angle P congruent to angle Q. Let's say we have two quadrilaterals. Okay? And I'm telling you that this angle is congruent to this angle. All you do to identify that angles are congruent, or to show that, is put a curved line in the angle. Now, yeah, I could do that for all of them because this technically looks like a rectangle, so they should all be 90 degrees. Okay? But this means these are the same, these are the same. Okay? Steve? Okay. So I just wanted to do a little bit of geometry today. Do you guys have any questions? Any of that? Sure. Okay, we'll come back to finishing that tomorrow. I want you to open up your homework packet to 6.3. Okay, guys, girls. Shh. All right, practice 6.3. Okay, I want you guys and girls to do, hey, Kevin, quiet. Okay, I want you guys and girls to do numbers 1 through 4, and then 9 through, hold on, 27. Okay, you have time to start. Okay, so listen, on 1 through 4, you need to tell whether the ratios form a proportion or not. So if they form a proportion, they have to be equivalent. So that's for 1 through 4. 9 through 27, you need to show your work. Okay, you're using cross products there. You need to show your work. So if you make a mistake and ask tomorrow, we can figure out what you did wrong. You have about 8 minutes to get started. Ms. Wingrove's going to pass back corrections. Okay, and explain something to you if need be. So you have your homework, and then if you still need to make corrections, don't forget about that. Okay? And I'll be around in a second.